to kick things off, I'll tell you why I wrote the book. I had a lot of time on my hands. So last year, a few things didn't work out the way I wanted it to, so I ended up with a lot of time to do house renovations, and I decided to write a book to introduce, well, not introduce, but to discuss Data Vault with a fresh perspective. And I've got a background in consulting on Data Vault projects. So typically what I would do is find out what the customer wants, establish standards and coaching personnel on site on Data Vault. And I felt it was maybe a good time to start talking or at least producing a book on Data Vault, because there's been a lot of things going on in the market, at least in terms of technology and businesses, and realizing that the advantages of things like data ops and so on, that really enterprise data warehouses are being tracked by business keys. Eckerson Group said that it's a tipping point for Data Vault last year, maybe if it was COVID affected or not. And when I write this kind of documentation for a customer, because I typically take over some space on their Confluence, I try to present it to the way that the business or the actual users of the methodology would understand. So that last quote there was an actual quote from the customer, that I produced all this documentation that, after you've been trained in Data Vault doesn't necessarily mean you know how to build a Data Vault. My engagements usually include Data Vault coaching on site, modeling as well, even advising on how to choose a tool or build it yourself. So, and my perspective is that if you could explain something simply, then you understand it. And when I started writing out that book, it turned out to be a lot more pages than I thought. I thought maybe that's simple enough to put together. And the other thing to understand is I really like this quote from Conway, that when you're building out your organization, your IT structures and all that, that it really reflects your communication channels. And I felt that described Data Vault quite intrinsically, that if you go to the market right now, you won't necessarily find a book or exact guidance on how to do industry standard Data Vault modeling, because everybody does their communication channels differently, or their business capabilities differently. And I thought that quote from Conway really sums up how you build a Data Vault, that there isn't an overall industry standard, but by you reusing the templates that are available in Data Vault, that you can build whatever you want out of the data warehouse that suits your enterprise, or how it comes together. And I've been writing a lot of articles, at least for the last 3-4 years. I was having them published on Data Vault Alliance, quite a few of them on LinkedIn, things about how we solved some business vault problems. What do you do with dead data? Modeling was a thing I published about 2.5 years ago, and this is in the slide pack that Chris is going to circulate, but you can click through and read along if you want. And there's more articles coming as well. Some of them, I don't know, John, how often you jump onto DVA. Some of them are inspired by the discussions that are going on in there, like the differences between zero keys and ghost records, and how to pick up a fake vault, when certain things in the standards aren't applied. How to build a business vault. I mean, even in my own engagements, this is aside from using Data Vault Alliance, is this is pretty mysterious to some customers. How do I build a business vault? What makes it so different to everything else? The book certainly gets into that, and the article as well. So the book itself, I split it into 5 parts. I start out with kind of describing the landscape. I mean, the book assumes that you have some background in data modeling or data architecture right now, because if you refer to the book in the first couple of chapters, there's a lot of links for you to go research yourself. I mean, if I had to write about everything that Data Vault touches or I've seen, Data Vault implemented on, it'll be maybe a couple of volumes just discussing those points, you know. So starts off with architecture, governance, a little bit about understanding business keys, smart keys, different types of keys you'll see in Data Vault, an example of time and how that is recorded and managed in a Data Vault. We then dive straight into raw vault, business vault, the peripheral satellites that sit around the Data Vault. The Data Vault automation, so really about the orchestration on what you could do with a proper Data Vault implementation, that you're not trying to build something that was maybe feasible in the 90s or the early 2000s, you know, overnight batches and the like, but you're trying to aim something that's more modern. With the cloud and everything, it means that data is available when it's ready. And this is the type of automation you should be looking to in your Data Vaults, especially around orchestration, right? Chapter 8, we dive into the record tracking satellite, which is the extended version of that. It is built for timeline correction. And we dive into a test framework, and of course, consuming data out of a Data Vault. And then the last chapter is about variations of the Data Vault, you know, that you do have these different types of data source models that you would ingest, and various variations of Data Vault that you can build around the Data Vault itself, you know, besides the raw and business vault. So the problem today, this is really about what conforming into a dimensional model means, right? If you use a metaphor of trying to paint a picture, your requirement is, I want to paint a Renaissance woman, right? Sweet. Here's my frame. I'll draw it in there. Everything's great. But now you have another requirement. I also want trees in my painting, right? So yeah, that's all right. I've got plenty of space to put that in. I'll draw trees on the side. But then your requirements expands a little bit. Says, I needed to show that it's during the day. Right, so that's okay, I've got space for that. I'll draw a sun and paint the background blue. But now another requirement comes in and says, I need to show that it's nighttime as well. Well, that doesn't really make sense, but you know, I've got one painting, I'll paint it in somewhere. So, well, I've got more requirements. I need to show a man somewhere in the picture as well. So, well, I'll show a man, I'll just draw a mustache, right? So, but I've got another requirement. I need to show a cowboy as well. Says, okay, I can do that. I can start smashing in these requirements into a single painting. Say, oh, but I've got another one. I want to have a car in that picture as well. It's like, well, it doesn't make sense. It doesn't even fit this whole painting that I'm trying to paint. But this is the sort of paradigm that you get when you're building something in dimensional modeling, especially if you treat the dimensional modeling as an enterprise data model, is that you try to force in too many requirements to the same data model, and you end up escalating the costs to do regression testing. And does the model still present the same type of facts? And you start building up this sort of technical debt. Whereas when we're talking about Data Vault, you don't do that. You componentize everything. You have all your requirements come in as different components, and they're available like a buffet almost that you can pick from, and then start to build your dimensional models based on what your requirements are. You know, maybe it is a mix of a car and the Renaissance woman. It's really up to the business, you know. But the Data Vault remains auditable. It keeps on loading data to it, maintaining the audit history, and keeping that agility in place as well. And all that data comes from is the business processes. One of the quotes that I showed earlier is that, you know, the enterprise warehouse in a Data Vault fashion is focused on the business keys. You know, and where does it come from? It comes from the business processes, and all these business processes are generating data, and all this data is being collected into the Data Vault. You know, within the data retention policies. They're all representing business rules and things that are being done, actions being done onto the business objects themselves or business actors themselves, right? And this everything here is in a peach color. In this scenario, represents raw data, but sometimes you would have a situation where maybe the raw data doesn't fulfill the entire business process, and you have to fill it in somehow, you know. And that blue or purple section in that diagram is where maybe Business Vault comes into play. It says, oh, I've got all the raw data, I need to derive this outcome over here and fill in the gap with the business process. A lot of the times this gap might be technical debt. So typically, or preferably, you'd want to solve it maybe temporarily in a Business Vault and have the raw system catch up to automate that part of the business process, and then likely supersede that temporary solution that you put in place, right? So all of this fits into a nice typical architecture diagram. We've seen this a lot of times. Data comes in on the left-hand side, it gets ingested as structured or semi-structured data. It gets staged, it gets loaded into Data Vault, model into Data Vault, which also includes streaming, and there's different latency of data, different speeds of data coming in, and then all presented as information to the business, right? So the book also gets into how to visualize that, how to define what is the raw data, what is it that we do to the raw data to refine it and ultimately to present it to the business and still do data science and on top of that and model more data into more of the business processes, right? And the book also recognizes that there's not always one way to deliver an architecture framework, you know, just like a data lake, there's multiple ways to do it. The same goes for a Data Vault. You could have raw and Business Vault being loaded alongside each other, which is directly loaded from a landing area, and just virtual dimensions delivered on top of that. But also, it dives into the pros and cons of maybe doing these types of different architectures, where maybe you would want to have the staging area be the platform, like a persistent staging for a virtualized Data Vault, and then another virtual layer that virtualizes that into information marts. It discusses the pros and cons for each approach, as well as still loading things alongside each other between raw and Business Vault, but still all physicalized from staging. And then maybe something that I think Neil Strange does with his DBT Vault is that he virtualizes the staging itself, where the Data Vault metadata tags are added just by applying views, which is a valid scenario. But also we dig into a scenario where we compare the pros and cons of having the virtualized Business Vault based on the raw vault. You know, what's good about that? What are the things to watch out for where it can become more challenging to manage? And then if you physicalize the whole thing from raw vault to Business Vault, you know, how do you do that? How do you manage the business rules in that perspective? And also with a view of adding query assistance tables, you know, if you need it. If the performance is starting to lag on your Data Vault, then what are the structures that we can use to optimize that, right? So all of this forms the framework of how a Data Vault should be delivered, with these variances in options. And the book also discusses where you would apply certain rules, hard rules like time zoning the data, trimming fields where you need to, getting rid of carriage return, basic cleaning of the data, integration rules, business soft rules, derivations, which you would build into a Business Vault, and then finally functional rules that actually makes the data presentable to either a mart or, you know, a tool like Tableau or Power BI or something of the like, right? So I'm rushing through this because there's I want to get through what the book actually covers, and I'll get into the exercise. So towards the back of the book, we do discuss different variations of Data Vaults. I mean, ideally, raw and Business Vault, we're modeling the business objects and business processes, but you can still reuse those same structures to build yourself a metric vault or a Jira vault or a schema vault, whatever you like. I mean, the benefits you get out of it is the repeatable patterns, it is the audit history. So the same loading patterns you use for raw and Business Vault, you can absolutely use for the other types of vaults you can build out there, right? So we get into the classic stuff, the hubs, links, and satellites, dependent child keys, multi-active satellites, CDC. I call it CDC. I think the Data Vault 2.0 book calls it non-historized links and satellites. It's basically the same thing. You don't need to check that the record is new. By definition, it is. So business vaults as an application of the same raw vault loading templates. The only difference between is being the derived content. And when we dig into the peripheral stuff, record tracking, status tracking, effectivity, scenarios using those, as well as how to query those as well. And then the new pattern, the extended record tracking satellite, which we'll dig into. We also discussed the reasons for satellite splitting. Obvious ones are rates of change. Another one is whether your platform that you're using doesn't handle a satellite that's so wide. For example, 600 columns might be bigger than the 8 kilobyte width of a SQL Server table, and you probably want to clump together the data that's critical that you'll be probably querying together. So someone else is obviously involved in doing that. Other things like splitting between personally identifiable data, particularly for GDPR. And I mean, the reason why you would do that explicitly, not just because you could isolate it into its own schema and people don't know that there is this data, but the one defining thing about this sensitive data, this personally identifiable data, is that it hardly changes, right? So if we're tracking a person's birth date and we split that satellite based on non-sensitive to sensitive, then you would probably only have one record for a person to have his birth date. And in that sense, when you have to do something like an Article 17 for GDPR, you can go straight in there. There's only probably one record per person. It's far easier to manage this in the data vault in terms of splitting satellites in that sense than it is if it was on a data lake where that type of information could be propagated all over the place, right? So we also dig into things like modeling scenarios and what the pros and cons of choosing one pattern to model it versus another. And this shows an example of where something like a multi-active satellite can be really powerful. I wouldn't advocate always using a multi-active satellite, but it does have its place in certain scenarios, rare as it can be, but the book does highlight it as well. The difference between a satellite with a dependent child key and a multi-active satellite, and comparing where you would use a status tracking satellite against a link table versus an effectivity satellite with a driving key. Why would they be different and how it would be different? So it digs into that as well. Then finally, we get into the automation bit where what we're saying is, look, there is all this stuff that's included in the data vault, but really, it's three kinds of loaders. You have a sat loader, a link loader, hub loader. All these variations fit these three very simple loading patterns. And the pattern itself is just a matter of landing the data, staging it, and then a configured way to identify where the staging data goes to, which hubs, links, and satellites that are related to that packaged piece of data. And that terminology on packaged data is really important because they will have an applied date, which is what we're going to get to. And obviously, after everything's loaded, things that are dependent on each other, you'd run tests because, in a Data Vault 2.0, we don't explicitly say or enforce referential integrity with foreign keys. We imply it, and the way you test it is configured in the test framework. So the same same staging and loading configuration is also used for the testing configuration, saying, oh, this is related to that. Are there orphan records? Has all my staging data made it to the target data vault artifacts? And the book dives into the SQL, into the framework that should be in place. Also a recommendation around warranty periods, because do you need to run all of these tests? Maybe you only need a subset for it, because every time you do execute queries, of course, there's a charge on your cloud billing. So there's pros and cons to decide and design when you're putting this test framework in place. We also dig into the fact that since all this is pattern-based, the methodology of delivering it is also template-based. So the same templates are used between teams, self-organizing teams, but always conform to the same standards. And there's a governance implied. There's a reviews implied. There's testing implied. So that the data vault can be developed concurrently between teams, as long as they're sticking to the same templates and recognizing what is a business object to the business. So if you have a hub account, what else would be loading to a hub account? What other data sources? And there could be multiple business processes or multiple systems that feed a single business process that are loading to the same data vault, right? And each of these teams can be running their own flavor of Agile, of Scrum or Kanban, whatever the case may be. But it's a template, it's repeated. It's a product backlog, get the work in, get the model configured, get it reviewed, approved, and get the data loaded in. So it's a repeatable pattern. So that the data vault is in a state of eventual consistency, right? So we also dig into the various consumption patterns, how to query data out of data vaults, because we recognize that, if we were looking at a dimensional model, you got one table, a data vault model, you got lots of tables. What are the ways you can query it? And there are patterns to do that as well, to extract from a satellite, to use a PIT table, a point-in-time table, where we can simplify the queries around data vault structures that have indexes, right? And on top of that, or alongside it, as an option, there's also patterns to actually build marts over this. And these are repeatable patterns. These are that they don't have to be manually written code. Just like loading the data vault, there are patterns to query the data vault. So if you needed to shorten the distance between one business object to another, there are bridge tables that you can build as well, and the book gets into that and how to query that and how to build it as well, right? The satellites themselves, so if you pause for a minute and you look at what the structure would look like, this satellite only has one descriptive column balance, but you can imagine it has many, right? So in Data Vault 2.0, we don't update records in place. We always have a virtual end date, which is virtualized with SQL window functions. So DVAPPTS is your applied date. Now you can think of it as an extract date, and each extract date comes from a package of data that we get from the source platform. And as we load it, this applied date being different to a load date, it means that you can actually supersede a package if it's been corrected. So in other words, when you're querying it, you're querying the corrected timeline for this package of data, right? And this is what part of the exercise what I'll show now is going to explain. So bear with me as I go through this. I'm just want to explain everything and keep notes and questions, and I'll jump back into this if we need to. But if you think about it, policy timeline, claim timeline, those would typically be what we call business dates, right? But when they are applied is when we know about that data. So that becomes our applied date, and it's not really our package date, right? So if we're talking about insurance, insuring a red car, for example, we could have got that data on the 13th of the 12th, and we know that a policy is coming in, and we really, for some reason, have all the history of claims, right? To say, oh, okay, all the claims are against this red car. If we get another package of data, it might be a retrospective change on the business date. It doesn't really matter. It's really about that package date, right? So we know that actually that first claim is against that red car, but the other two claims are against the blue car, And this could be extended further by another package coming through that says, actually, on this date, it's a red car, Now, again, we've gone back to the original scenario saying the claims are actually against the red car, but there is a fact there that the changed color. Why is that? Is that intelligence? We want to know, And because of this difference in applied date and load date, we can also get away with talking about versioning it, which we'll get to in a second. But if we do more retrospective changes, we say that the car was blue at this date. We can also see that on a timeline if it's applicable. So when it comes to versioning, when the packet arrives and it's got the same applied date, and it's different to what we know about this car before, it would supersede that what we previously know about it for that package date. Even though the date, the business date is the same date, the applied date is the same date, the load date acts as a version date of these records, right? So when we look at the table itself, it would kind of look like this with the virtualized applied end date, right? And this is when I'll flip to a quick exercise. if we had to look at that table itself and querying it on that date, which is the 13th of the 12th, which you said before, right? We take that out to say yes. Querying that date will return everything. All the claims are against that red car, right? So if I undo that and I say let's pick a 2020-04-15. Let's go 2020-04 and 15, right? So that changes things a little bit. And if we have to query that again, you know, we can see that at that date, we know that's actually the claims were against, the first claim was against the red car, and the next two claims are against the blue car, right? And if we wanted to throw another big date in there, maybe we go to 2020-12-17, right? And this is, I guess, where it gets interesting. Is now we see that there are claims applicable to the red and the yellow car, but looking at the load date, it is newer than the red car, right? So that tells us that actually this is the correct version of this timeline. This is the correct instance of this, what we know about this car, right? So let me switch back. So using that same concept is that where we get into the extended record tracking satellite. So this was introduced fairly recently, about maybe 2 years ago, and it is a data-driven method to correcting timelines, even going way back, which I will switch to the other slide pack. The reason I did that is because you know, this stuff has been worked on before. So data-driven timeline correction. So this is the scenario, right? We've got the stage data in green coming through, and again, one descriptive column, city name, and it's loading a satellite table because we don't know anything about this guy before we load a record. The hash diff is 6D, right? And that's really important. Timeline's on the right. So on Wednesday, we get Wednesday's record, right? And because it's also Sydney, we won't load a record into the target satellite because it's the same. In satellite, we're only tracking changes, right? But now what happens if on Thursday we actually get Tuesday's record? You know, this is just a hypothetical, you know. If Tuesday's record comes in on Thursday, naturally 6E is different to 6D. We must insert it. But now the timeline is not correct. The timeline says, your latest thing we know about this entity is that it's in Brisbane, but it's incorrect because Wednesday record would have been back to Sydney. So how do we fix this, right? And this is the scenario we have that could happen. It's a real life situation where you get data that's loaded out of sequence. So it should be 6D. It's not. So the extended record tracking satellite is a peripheral satellite. It's not meant to track actual attributes and business process data. It is sort of a helper table that is attached to every hub and link. One of these is attached to every hub and link, right? And in itself, it would be managing all the satellites around a hub, and one of those would be managing all the satellites around a link. So it will have the hash key coming from its parent table shared with what the satellite's also been loaded, right? Now, keep in mind, this is record tracking extended, so it still does the same sort of functionality in terms of tracking that record, but it's extended because it does something a little bit different. Instead of hashing the record timestamp, we're actually recording the satellite timestamp and recording which satellite it belongs to in a column called rec target, right? So with that hash diff alongside this XTS, it's called the XTS, we're tracking every occurrence of this record as it appears in our raw vault or business vault. It can be used for both, right? So we have 5 scenarios where this becomes really effective. the first three are pretty easy, pretty straightforward to get you into it. And then we'll get into the timeline correction bit, right? So back to our original scenario, we'll track something that never changes, right? So in addition, we have a new satellite, bottom left-hand corner, and a new timeline. And this timeline is just about that hash diff for that satellite table, right? So what happens is Wednesday comes along, 60 is the same. There's no insert to the satellite table, and we're simply just recording there is a hash diff that's arrived from that satellite, right? And Thursday's record comes in, but it's also 60, so we just record what the hash diff is, and there's no change to the satellite itself because the record never changed, right? In scenario 2, there is a daily change. So Monday comes in, 60. Wednesday comes in, it changes. So there's a record in the satellite. There's a record in the record tracking satellite, with just the hash diff. And Tuesday's record comes in on Thursday, but it's also different. So it looks the same, but you know, it's different. So scenario 3, record comes in on Monday. Wednesday's record comes in and is different from Monday, so we do insert to both. And Tuesday's record comes in, but it's the same as Monday, so it's actually not a change to the timeline itself. There's no insert to the satellite, but we still record the hash diff in the record tracking satellite, the extended record tracking satellite. So where it becomes interesting is this scenario. This is the same scenario we highlighted earlier. So now we've got the addition of the extended record tracking satellite, and this is what happens, right? So Wednesday comes in, there's no change. We insert nothing to the satellite. We still record the hash diff in the XTS. And now that we've got Thursday's record come in, we notice, oh, there's a problem, right? So what we do about that is that we recognize, actually, since the record before should be the same as the record after, it should be just copied as if it was inserted already on the Thursday. And you need something like an XTS to be able to track that, because the hash diff is available in the XTS satellite, right? And this can be done in a single SQL, by the way, which is also in the book. And finally, scenario 5, there is something that you need to keep notes of applying this type of scenario. Is that, let's say we have the same 60 arrive on Monday, and Wednesday's record comes in and it is different to Monday's. But what happens when on Thursday, Tuesday's record comes in and it is also 60? It's actually the same as Wednesday, not Monday. That means you must insert, right? It does look like it is a duplicate in the satellite, but it all depends on how you query the data, whether it's a duplicate or not, right? You can definitely get around it using point-in-time table structures or the like, but you definitely have to insert it in, because this is telling you that the event of Wednesday actually happened earlier. So you must record it. You must meet the auditability of the data vault, right? So there's a couple of caveats which the book gets into a lot of detail, because you've now introduced this bytable dependency between XTS and the satellite itself, that now that you're relying on this hash diff being present in XTS, it's okay when the XTS has been loaded before the satellite. It's okay if it's been loaded after the satellite, because the timeline correction is really dependent on the record before and never the record after, right? And you want to avoid where it's too dirty, where the XTS is out of date, like completely out of date. Then you might actually miss data that you need to populate into the satellite table, right? So there's other considerations like, you know, if you're doing timeline correction, then it probably would influence the way you design your business vault satellite as well. One easy scenario to think of is if your business vault for some reason is tracking rolling balances. If you're doing timeline correction, then it won't work, right? So rolling balances will probably be relegated to a dimensional margin, where it should be anyway. So, and of course, if timeline corrections happen, what does it mean to the rest of the business? Have you set out regulatory reporting that's based on data that was now corrected? Do you need to create a correction that you need to pass through to whatever regulatory body, or if it's an accounting type system where you say, look, it's closed, but you need to include this to the next billing cycle or next reporting period. So it's touch and go. How you broadcast the change in the timeline, right? Of course, this is a data-driven approach. The benefits out of it is that corrections are done immediately. The alternative of this is if it was managed by system processes, you would typically hold the batch, put it that way, until you get the data that's right in the right sequence, and then load the rest of the data in the correct sequence, where this approach says, no, look, just load it in, I'll fix it when it comes in, right? And the other thing is that because it fixes as it comes in, I've definitely seen it at a big customer where they've loaded things out of sequence and they've spent weeks and months correcting reports, because now that the data is different, the reports are totally different, right? So that is in essence the XTS satellite, which Chris wanted me to focus on for today. But just to close off to the rest of this is that the book does get into model scorecards, which is a Steve Hoberman inspired card that I put together. Vendor tools scorecards. There's also a schemato on how to build your own tool for data vault automation, which I've done twice. I've done one for using SAS, another one where the customers, technicians were specializing in Apache Spark and S3 buckets and the like, and I led the customer who wasn't Data Vault literate to actually build out an automation tool using their own tooling, which is based on Scala and data frames and Apache Spark, which was really fun stuff. And of course, the book, there's a GitHub library with all the stuff that's all the art that's been used in the book is freely available to download and clone. And I've also recently just put up an errata to there to, little mistakes I found in the book, which I did find one when I was putting this slide together, but it's all there, it's all available. And it's online, it's on Amazon, you can reach out, and I'm open for questions.